All right, so today we covered scientific notation. So first, just getting into why does scientific notation exist? What is it good for? Scientific notation exists to shorten extremely large or small numbers with a lot of zeros. I'll show you how these are generally formatted. The format for scientific notation could be something like 4.17 times 10 to the 7th power. Now, a couple notes about this. Our number that is being multiplied by 10 to the whatever power must have only one digit to the left of the decimal. There should be only one digit in the ones place. The tens place should be vacant. All right, you can have however many decimal numbers you want off to the right, but there can only be one off to the left. It will always be times 10 to the something power. I used x here just as a placeholder. In general, if your exponent is positive, then the decimal will move to the right. If your exponent is negative, then the decimal will move to the left. And this is always how these problems are going to be formatted. It will be a number times 10 to the 7th power, or 10 to the something power. Sometimes it's positive, sometimes it's negative. So we did 4 examples in class. The first one was we rewrote in standard form. So we were given 2 problems and we wanted to rewrite them as a standard number. So our first one was 5.5 times 10 to the 4th power. So what we did is we wrote 5.5. So I wrote 5.5 and I just put a decimal here for 5.5. And then I moved this 1, 2, 3, 4 spaces, and that is where the decimal would have wound up, giving me 55,000 is what 5.5 times 10 to the 4th power is. Likewise, for the example from above, 4.17 times 10 to the 7th power. Again, we move the decimal to the right because that is a positive exponent. And we move it to the right 7 spaces. So I would start here and go 1, 2, 3, 4, 5, 6, 7, all the way down. And if I do that and started here, 1, 2, 3, 4, 5, 6, 7. So we have here that this example that I gave would be 41,700,000. And again, this goes back to why does scientific notation exist? It is a lot quicker simply to write out that expression than it is to write out all those extra zeros. We also did 2 examples rewriting in scientific notation from standard form. So we started with 19 billion. So we had 19 with 9 zeros at the end. So step 1, we wanted to rewrite this. So we would have our decimal right there. That's where we want our decimal to be. The question is, how far would our decimal have had to move in order to get to where we want it? So let's find out. We would have had to move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces to the right. So if I rewrote it there, I'd have to move the decimal 10 spaces to the right in order for it to equal its original amount. So I put 1.9 times 10, and since we would move 10 spaces to the right, we use a positive 10. The next example is kind of the opposite. We want our decimal to be here because we want only one number to the left of the decimal. So we should end up with 3.12 times 10, but this time it would be to the negative power because to get back to our original decimal, we would have to move 1, 2, 3, 4, 5, 6, 7, 8 spaces to the left, meaning my answer for this one should be negative 8 because I have to move 8 spaces to the left to end up at my original spot. And that is all we did in terms of scientific notation. We are doing more with it. Tomorrow we will be multiplying and dividing scientific notation numbers by each other. And that was what we covered today.